Welcome back to part 3 of adding and subtracting rational numbers. And now we're going to get into the subtraction side. The rules are going to be very much the same as they are for adding rational numbers. And they're going to start us off with another video. Maybe. They're slow.
To subtract rational numbers in different forms, write the numbers in the same form. One way to subtract a decimal from a mixed number is to write the mixed number as a decimal. This method works if the mixed number can be written as a terminating decimal. Next, find the difference. To subtract the decimals, rewrite the subtraction as addition and add its additive inverse. Follow the rules for adding negative decimals. Another way to subtract rational numbers in different forms is to write the decimal as a fraction or mixed number. Use this method when the fraction or mixed number cannot be written as a terminating decimal. If the fractions have different denominators, rewrite one or both fractions using a common denominator. To rewrite a fraction, multiply its numerator and denominator by the same number. Next, subtract the fractions or mixed numbers. Sometimes when you subtract mixed numbers, the fraction in the first mixed number is less than the fraction in the second mixed number. In this case, rename the first fraction in order to subtract.
Looks like what I showed you.
Then, rewrite the subtraction as addition and add the additive inverse.
Alright, well they showed you pretty much what I did with that mess right
Finally,
there.
Simplify the difference if necessary.
And they made it look a little quick, but I hope y'all were able to catch on to that. Don't worry if you didn't, we're going to be going over some of this. So the instructions say to use the chart below to find out how to subtract rational numbers when written in different forms. In words, we can say if fractions are decimals that terminate, then use the decimals or fractions to solve. So here they have an example where 1 over 10 became a terminating decimal 0.1, so you could use it as just decimals to solve it. They also could convert 9/10 to a fraction and solve the fraction. So if they terminate, then you get to use either one of them. However, if you end up with non-terminating decimals, for example 1/9, 2/3, things of that nature, then you're going to have to work them as fractions. So 1 over 6, that's going to be a non-terminating decimal. So you have to convert the 1.25 into the fraction, which is going to be 1 over 8, and then solve it from there. So they want us to start off by making an estimate on this number here. We have negative 3.27 minus a negative 6.7. And my estimate would be, I'm going to change that to minus 3, and then negative times a negative is plus 7. So my estimate is going to be about 4. And whether or not that's going to be correct, I don't know, because they're not giving me a way to check it. But that's what my estimate is going to be, something close to 4. Now, we're going to take from here and look at their rules, and you can see what they did. They took the negative 3 plus a minus 6. I did plus a minus 7 because that was closer to 7. They did plus a minus 6. Minus a negative 6, which became plus 6. They came up with 3 for theirs. When you worked it this way, you had the same thing, only now you're going to find the difference this way, and you get 3.43, which is pretty much right there in between 3 and 4 that I estimated. Because the absolute value of 6.7 is greater than the absolute value of negative 3.27, the sum is going to have the same size as a 6.7. How do I teach y'all to say that? The sign in front of the larger number, it goes in front of your answer. Alright guys, it's your turn. Pause the video, solve this problem. Go. Did you work the problem? Let's see how I do it. First thing I'm going to do, get my mouse over here, I'm going to make the ugly problem pretty by multiplying my signs. So now I have 3.58 plus 2.9. From here, I'm going to take and go off to the side so I can align my decimals. 3.58 plus 2.9. Annex zeros is needed. Add them up, and that's going to give me a 6.48 for my final answer. Come back over to this side, plug it in, 6.48, check my answer, and the answer checks. Easy math, anybody can do this stuff, even you. But what if we have to subtract a couple of fractions or mixed numbers like this one? They're going to have us move through the steps, and they're going to show us how they would like to do it. I wonder if they're going to go for an improper fraction this time, or if they're going to go for a mixed number. First thing they ended up doing, improper fraction. 3 times 5 is 15 plus 1 gave them 16 over 3. Next we have 9 times 4 is 36 plus 5 is 41 over 9. Notice your negative signs are still there. Next, if it was me, I'd make the ugly problem pretty in this step, but they're not going to do that. They said, well, 3 goes into 9 3 times, and 3 times 16 is 48. So now they have their common denominators, and now they're going to acknowledge the fact that you're adding here. Even though it's a minus and negative, negative times a negative is a positive, so you're actually going to be adding. Hey, what do you know? They actually made the ugly problem pretty. Awesome. They must be taking lessons from me finally. Now you got the common denominator, 48 plus 41. Let's see if I can zoom in just a little bit for you. Nope, apparently not. That's going to give me 89 over 9. And that, as a mixed number, is going to become 9 8/9 for our final answer. No reason to type it in there because they gave it to us right here. Not too hard, really. Just change them to improper fractions and work them like you worked all your integer problems. You know how to do both parts. We're just putting them together in one problem now. Alright, boys and girls, this one belongs to you. 1/2 minus 2 2/5. You pause the video and work this one on your own. Go. Did you get it? Let's see how I'm going to do it. Now we couldn't change them to improper fractions, or we could probably work this one just like it is, and who knows, maybe I'll feel froggy and work it both ways. So I'm going to start off by going to improper fractions. That's going to end up giving me a negative 1 over 2 minus, do my whole Texas thing, 5 times 2 is 10, plus 2 is going to give me 12/5. Now my least common denominator is going to be 10. So my problem is going to start off looking like that. 2 goes into 10 5 times. 1 times 5 is 5. 5 goes into 10 2 times. 2 times 12 is going to equal to 24. Now signs are the same. Find the sum, which is going to be 29 over 10, leading to the final answer of 2 9/10. That's one way to skin the cat, but let's do it the other way. Now I'm going to take this problem here and just go ahead and find least common denominators. So 1/2 with tenths, that's going to become a negative 5 over 10. And then minus 2 and put tenths here, that's going to be 4/10. Once again, signs are the same, so I'm going to be finding the sum, which means this time I'm going to have 2, 5 plus 4 is going to be 4 over 10, and you know, I'm sorry, not 4 over 10, it's going to be 9 over 10, 9 over 10, and I just realized I forgot to do something on both my problems. The sign in front of the larger number goes in front of your answer. So either way, your answers can become a negative 9 over 10, and that is good quality supporting work to show you how you get there. We can go back to the problem page, type it in, and check it out. Negative 2, and what was that? 9 over 10, accept, and check our answer. The answer checks well. But what if they give us an algebraic expression, meaning they give you variables? So here we have x minus y. Not a big deal because they tell us what x is, they tell us what y is. We just have to be able to subtract those two numbers. So moving through the slides, we're going to take now, and method 1 says evaluate using decimals. I think we can do that. So we're going to take the original problem where x was going to be negative 2 4/5. y was going to be 1.4. Negative 2 4/5 as a decimal is going to be a negative 2.8. And let me zoom back down so I can actually find my thing. There we go. Except that part. Oh, didn't answer that part. And so let me go here. Negative 2.8 plus, that's going to be a negative 1.4. Except, and when you do that, you get the final answer of negative 4.2, because you end up saying positive times the negatives, and negative signs are the same, find the sum, and all that happy jazz. Method 2 involves using them as fractions. So in this case, we're going to take this 1.4 and we're going to change it to a fraction, which is going to be 1 4/10, and 1 4/10 simplifies to be 1 2/5. You've got a common denominator here already. That's going to make it easier. Now the question is, are they going to work it as mixed numbers, or are they going to work them as improper fractions? And they chose the improper fraction route, changing each one of these numbers to the improper fractions you see here. Now signs are the same. Find the sum, and the sum of 14 and 7, that's going to become 21. Why they're doing this, I don't know. Don't do this. Don't. Just signs are the same, find the sum, and that's going to lead you to the negative 21/5. Sign for any larger number goes in front of your answer, which gives you the final answer of negative 4 1/5. Now it's going to be your turn to take and solve this problem on your own and see if you can get it right. And maybe it'll generate here in just a second. Finally loading, and it says, ooh, another algebraic expression. Work the problem. Did you do it? Let's see what I end up getting. So A is going to be a negative 1.6 minus B is going to be a positive 7/10. Now I think I want to work these as fractions. Fractions are our friends. So I think I'm going to do this as a decimal, because this would be a super easy decimal problem. Negative 1.6 minus 7/10. That's 0 7/10. From there, we could take and say signs are the same. Find the sum, which is going to be 2.3. Sign for a larger number goes in front of your answer. Negative 2.3 is what we should get for an answer. So come back over here, and oh, it's not going to want that. What you want to bet? Negative 2.3. Accept. Check it. Hey, they said it was good working it that way. I'm glad. And with that, we have made it to an apply problem, and that apply problem doesn't seem too exciting about loading, and you know what? That's okay, because I'm not too excited about doing it. I think we have done a good job of working problems like this one already. We've given you lots of demonstration, and we have plumb beat this horse to death. So now it's your turn to get in there, log in, download your assignments, get started on them, and get them done so we can check them tomorrow in class. This is, I think, is going to be our first true advanced math type of assignment.